Hello everyone, this is my CS50 final project titled Automated Match Pairing System. My name is Guru Vignesh V. My edX username is Guru Vignesh 2580 and my GitHub ID is Guru Vignesh V45. I am currently recording this video from Virudhunagar, India on Jan 6, 2026. In this presentation, I will demonstrate how my project automates Swiss system tournament pairing and scoring for board games like chess. Let me quickly discuss about my project's overview. The automated match pairing system is a Python-based menu-driven application designed to manage Swiss system tournaments. The project automates player registration, match pairing, result processing, and standings generation. Players are paired based on their current scores and ratings. Repeated matches are avoided, and buys are handled automatically when required. The system also validates user input to ensure data accuracy and displays updated standings after each round, closely reflecting real-world tournament behavior. Now let me briefly explain how the project works internally and how the code is structured. The entire application is implemented in a single file called project.py as required by CS50. The execution starts from the main function, which controls the overall flow of the tournament. Players are stored in a list of dictionaries and a set called played pairs. It is used to ensure that no two players are paired more than once. Player registration is handled by the register player function, which validates names and ratings and raises error for invalid inputs. For each round, the generate pairing function sorts players based on score and rating. It creates a Swiss system pairings while avoiding repeated matches. As the number of players for one player automatically receives a buy point. Match results are processed using the update scores function, which updates player scores for wins, draws, and buys. Current rankings are displayed using the standing function, sorted by score and rating. Let me quickly explain the output of this program. It begins by asking how many players are taking part and quickly records each player's name and rating so it can see the field. In round 1, everyone is paired purely by rating, first opponents for all, and you enter the game results, so the program can update each player's score, giving 1 point for a win, half for a draw, and 0 for a loss. From round 2 onwards, the interesting part is the standings. Before creating new pairings, the program resorts all players by their current scores, so that the leaders are grouped together. The middle of the table contains players on the average scores, and those who are struggling are near the bottom, each bracket facing opponents with similar performance. After the standings, round 2 pairings are displayed. While forming these new pairings, the program checks that no two players meet more than once, so it skips any opponent that they already faced and instead chooses the next valid player on the same score. The same process repeats in round 3, and by then the standings clearly show who has pulled ahead. Players on 3 points have won all their games, those on 2 or 2.5 are close behind, and the rest are spread out down the table, according to how many wins and draws they have managed. Once the final round's results are entered, the program builds the last standing list, which serves as the final ranking of the tournament, from the overall winner at the top to the lowest scoring players at the bottom, and then the tournament clearly ends. To wrap things up, the short text file is just checking that our player registration setup is safe and reliable. This test file checks that register player reject invalid input like a rating written in words or name made only of digits by raising a value error. Its output is simply 3 pausing all the tests. Thanks everyone for your attention and support.